Episode 11, Spaceplanes. You're listening to SPEXcast. I'm Phil, and today we have Augie.
Hi, everybody.
Cole. Hello. And Alex joining us today.
Hello.
And we're going to talk about space planes. But first, we have a news segment. Augie's going to take it away. There's some new space news going on.
Yeah, some pretty crazy news. We got a bit of a data dump last Friday. Basically, SpaceX on Twitter and Instagram announced they'd like to send a Dragon capsule to Mars by 2018. So the 2018 deadline is pretty insane.
Yeah, that's insanely close.
Yeah, as of right now, there are only two organizations that have ever sent something to Mars successfully, and that was Russia and the United States, and we've only done it maybe 6 times.
You mean in terms of something on the ground?
Something on the ground on Mars, yeah, not just orbiters. But
Hasn't SpaceX? We've always known they wanted to go to Mars. So is it just that now they put a date on it? And
yeah,
they put
so literally their mission statement is they want to colonize Mars.
Right.
And so this is basically not the first step, but just another step on that mission. And what I find the most crazy about it is the Dragon capsule, compared to something like the Curiosity rover, is much, much heavier. They'll be able to, with their new Falcon Heavy rocket, send something like 29,000 pounds of payload to Mars. And for perspective, the Mars Science Laboratory, which is what brought Curiosity to Mars, which is the rover that you see pictures of on Twitter, it's our most recent rover, that only weighed 8,400 pounds.
Wow.
So it's insane, yeah. The difference in mass that we'll be able to take, I saw a plan. So obviously SpaceX hasn't really released or announced anything else so far.
Yeah.
They haven't even talked about what the payload will be. But I saw people doing calculations online that talk about actually putting a sounding rocket inside of the Dragon capsule, and then with that you'll have the ability to boost back to Earth and do a Mars sample
all the way to
mission.
Earth with the sounding rocket?
All the way to Earth, yeah. So since the atmosphere on Mars is a lot thinner than the atmosphere on Earth.
And the gravity is weaker as well.
The gravity, exactly. So it doesn't take much to get off of Mars' gravity. So with the sounding rocket, you could get from Mars back to Earth.
Wow. And yeah, so they're sending the new version of their Dragon capsule.
Yeah.
So not the one that's docked with the space station, but the one that's intended to carry people to the space station and beyond.
Yep. So it'll be the same capsule. Obviously, this won't be a crewed mission. It won't be a crewed version. I mean, it'll be the Dragon V2, which is their crewed version, but it'll be set up for taking cargo only.
Right.
Yeah, I know NASA had a study that came out about the Red Dragon, and that was a sample return mission. That's one of the things that they're very excited about, theoretically having the capability of. But, we don't know yet how much they're going to put on that Dragon, because NASA's not paying a dime for the entire thing. They're giving supervision and data, but nothing else.
So that's what was mind-boggling about the whole announcement, because a lot of people have thought, SpaceX will get to Mars and soon, but that it would be mainly NASA funded. So what's crazy about this is that so far there have been no announcements for funding elsewhere. It's just SpaceX wants to do this, and because they've dramatically decreased launch costs, it'll be a good way for them to prove and start researching the things that they'll need for their eventual mission, which is literally to be a space transportation company to ferry people from Earth to Mars.
Right. And me and Cole were talking about this before the show, and it sounds like NASA's intended role here is that big brother, that mentor, not big brother in the 1984 sense, but the big brother in the sense that they've done it before with their rovers and things. SpaceX wants to do it, so NASA can help advise them with the mission operations.
Yep.
And SpaceX has got the launch stuff down for the most part, if they can get their Falcon Heavy off the launch pad in time. Because they have to vet the Falcon Heavy and then the Dragon V2 or a Crew Dragon before they can even think about this mission.
Right. So SpaceX has had a ton of troubles with deadlines beforehand. With any new company, you set a deadline and you try your best to make it, but oftentimes it'll get pushed back, especially in the space industry. So they've been touting next year or 2 years out for the Falcon Heavy for the past maybe 5 or 6 years. But right now it's projected to launch by the end of this current year.
But the 2018 date comes from the transfer window from Earth to Mars.
Yep.
And based on the orbits, it's when it's the cheapest in an energy from an energy standpoint to get to Mars. And so that's a deadline that you can't slip. Which is, so interesting things are going to come out of this for sure.
If they miss this, they'll have to launch in 2020 then. So it's not like, oh, we're 6 months away, we have to push it back. No, you'll have to wait at least another 2 years before you can launch again.
Yeah, and it really depends on how much you're thinking about slipping. If you slip maybe a month, then they might be able to recover it if they maybe expend the middle stage and spend more energy. But it really depends on how much you're talking about a slip. I know the NASA Insights mission, which was supposed to launch this year, has slipped to 2020 because they had an issue with the probe.
So they didn't slip till 2018, they slipped to 2020?
They were very worried about that mistake. I think it was an issue with contamination or something like that.
Yeah, and at the same time, NASA does work a lot slower than SpaceX. It's not necessarily, it can cause the companies to get bogged down, but if you look at someone like there's this person Dan Rasky who works for SpaceX or works for NASA, and he's been contracted to help SpaceX out before. And there's videos on YouTube of him talking about the differences in how NASA works and how SpaceX works. SpaceX works in more of a just try it mentality rather than the whole let's look at the box of all the different risks and let's check off everything before we do a launch. And so that's the kind of biggest difference between those two companies.
Yeah. Not to say one's better than the other, because they both definitely have their benefits and drawbacks.
Right.
But they're totally different philosophies of running a business.
Sure. And they can both benefit from each other. And that's kind of what the CRS missions have shown, is that the government can work with commercial entities and help them get access to space. So something like this Red Dragon mission would really never happen without NASA. I mean, maybe SpaceX would get there down the road, but there's no way they would meet the 2018 deadline, because NASA is helping SpaceX develop the Falcon 9 rocket and helping them, launch and actually have so basically a lot of their income, not most of their revenue, but a good portion of it comes from, resupplying the International Space Station.
And also the commercial crew milestones, like pad abort, which I'm not sure if you guys are familiar with.
Yep.
So, for you, Alex, and maybe some other listeners out there, the Dragon V2, also known as Crew Dragon, it's SpaceX's new capsule designed to carry people. And the way it works is it rides atop a Falcon 9 huge launch stage, and it has its own engines. So when it comes back, it can use parachutes, but the intent is, instead of parachutes, to fire its own engines and land with pinpoint accuracy. And so pad abort, those engines can also be used as an abort system. So if something goes wrong on the launch pad, to save the lives of the crew inside, it can fire the engines last minute and blast them away from catastrophe.
And they have a short video of this on YouTube. If you haven't seen it yet, I encourage you to check it out. The capsule goes literally 0 to 60 in like 1.3 seconds. Just outrageous.
Crazy.
And so that's straight up, too.
Is this to the pad abort? Is that to prevent it from crashing on the pad?
It's if in case the rocket for some reason blows up on the pad
or has some sort of anomaly that's not safe, then the computers will automatically trigger the Dragon capsules to boost our astronauts away to safety.
And the purpose of this is one of those checkboxes that, like you said, NASA assesses the risks and then works toward minimizing risk. Sure. So if you before you can send people to space, you need to prove that you won't kill them along the way. So each milestone in this commercial crew contract gives a payout. So it's not like we're paying you along the way to kind of develop this.
Right.
It's you work toward this goal, you pass that goal, here's your money, and then it's not that simple, but kind of.
Yeah, so that's how commercial crew works. It's not like, because you see in the headlines like, oh, SpaceX has $1 billion from commercial crew. It's just some crazy numbers. And what happens is they don't just get that $1 billion up front. They develop their technologies.
So they spend a lot of money first.
Like pad abort, then they get the money. So basically, NASA and the government, from a risk perspective, are still very risk adverse, because if SpaceX or any of these other companies like Blue Origins, they don't meet their government contracted milestones, then they don't end up getting the money.
Which is great, because that drives super fast working companies like SpaceX, Blue Origin.
Sure.
Even ULA the United Launch Alliance seems to be like getting
doubling down and getting, So it's good for our tax dollars, because we're not just giving them away to a company and then having the company say, oh, thanks for the $1 billion. We tried, but we just really couldn't get it working.
And it also, along the way, reduces risk. And I think this whole idea, and I'm really psyched about this, because not only the 2018 date is soon, it's kind of critical, like they can't slip, and it'll promote the interaction between NASA's sort of research risk mitigation standpoint and SpaceX's super accelerated, heavy development, trying new stuff.
Right.
I think it's a
It'll
really
kind
good
of
balance.
validate their method too.
And I hope SpaceX isn't the only one. Like if TJ was here, he's kind of, I don't want to say stuff behind his back, but he's a real big fan of SpaceX.
Yeah. I mean, we all are big fans of SpaceX and NASA, but TJ definitely has a big preference for SpaceX. That's true.
Yeah, he's not here, so we could say that. But I hope that NASA does this with Boeing, with Lockheed, with United Launch Alliance, with Blue Origin. I hope all these companies, and even I hope they work together. It's better than if they're on their own. And I don't know. I don't know what to expect for the mission itself, the payload. But
right, actually, in software, what more of NASA would do is waterfall, which is kind of incremental and working towards that longer goal. Like a government contract. And so, would you say probably SpaceX to kind of balance that out is more
agile?
Maybe not skunkworks or agile, something more a little evolutionary or rapid prototyping, perhaps.
I would definitely agree with that. Actually, I think Lockheed Martin's experimental division for aerospace is called Skunkworks. So is that where where's the name originate there?
It is. I have heard it used in Lockheed Martin. That was the first time I've heard it used.
So maybe that's how the software industry got it. Yeah. So should we maybe get into Spaceplanes a little bit?
Yeah. Yeah. We kind of digressed a little bit. Pretty long conversation though.
Pretty long news statement. But what is interesting about the whole concept of Spaceplanes is that with rocket reusability and companies like SpaceX and Blue Origin's working to perfect re-landing the actual vertical rocket, it kind of makes the whole space planes economically much less feasible. But there are still some cool space planes in the works, and there were a ton of cool space planes in the past. So that's kind of what we're going to talk about today and just go over them and their history.
Yeah, and we can come back around to that cost-benefit analysis, if you will, later on in the show. But let's talk about successful space planes, not so successful space planes, and just the technology and freaking coolness about them.
Okay.
So when we're talking about space planes, we're referring to a vehicle that can go to space and return to Earth, basically gliding down like a plane.
Yeah.
So it would land on a runway. For example, the space shuttle was a space plane, but it's not the only one that's been developed. And they're like, yeah. Why don't you guys take it away?
Yeah, so a spaceplane is essentially a hybrid between an aircraft and a spacecraft.
Yeah.
So it goes up and comes back down, and in space it acts as a spacecraft, and in the air it acts as an airplane, and it will just glide back to Earth. And to date, let's start, I guess, with the successful ones. There have been 6 successful spaceplanes that have flown and returned to Earth. The first is the North American X-15, which was flown in the 60s, and actually still has the highest speed record for a manned powered aircraft, and this was like Mach 6.7.
So is this Chuck Yeager?
Chuck Yeager, I think, was on. I can look that up real quick.
Yeah, Chuck Yeager, I think, was X1, but we just did a quick search, and it looks like Neil Armstrong was actually one of the pilots. So
yep, Neil Armstrong.
So, do you know much about?
Joe Engle.
Do you know what engine powered the X-15? Was it a rocket engine or an air-breathing engine?
So the X-15 used a single XLR-99 rocket engine, which could generate 250 kilonewtons of thrust. It used ethyl alcohol and liquid oxygen as its propellant.
Interesting. So is ethyl alcohol similar to kerosene, RP1? Rocket propellant one that's used in typical...
Yep. RP1 is more common, but ethyl alcohol is actually like drinking alcohol. That's what you would use.
Really?
And so that's kind of what mixes with liquid oxygen.
Okay.
Yeah, they also had, they used anhydrous ammonia and liquid oxygen for another one. That was the XLR-99 engine. So the first one, so there are basically 2 versions. Reaction Motors is a company that built the XLR-11 liquid rocket engine,
right,
which used ethyl alcohol. And then the XLR-99 engine used anhydrous ammonia as the propellant. So they were doing a bunch of different prototypes under the X-15.
Right. And not all space planes have taken off under their own power. So what did the X-15? I have a vision in my head, and I think I'm thinking the wrong thing, but it was like a manned rocket, like a manned missile, and so when you're I'm thinking of a giant jet bomber with what looks like a really oversized air-to-air missile with a little cockpit, and then they drop it, and it goes.
That's exactly how the X-15 worked. It came out of a B-52, and they would basically drop it off, kind of like Richard Branson's Spaceship One and White Knight One, which I think we'll get into in a little bit. But they would drop it off, and then they would ignite the rocket engine and just boost it up to space. Essentially, they would break the 100-kilometer border.
Wow. Yeah. So, how did it come back? You said we defined spaceplane as something that it returns back to Earth like a plane. Mm-hmm. So did the X-15 land back on the runway?
Yeah, so it would just glide back using aerodynamics. Essentially, it had a wedge tail, which gave it hypersonic stability, and then it had just essentially wings that would allow it to coast back.
Awesome.
So next up, we have the Space Shuttle, which I'm not going to get into much. I mean, that was basically launched. It had almost 100 different flights. Most people know a lot about that. But
it's a podcast in itself.
Right. So we'll skip over that one.
Well, I want to mention one thing that I think is really interesting. The Space Shuttle, it did take off with like a huge fuel tank, the huge orange fuel tank, and solid rocket boosters. Flying back to Earth like a plane, it's just super interesting to me. It entered the atmosphere from 17,000 miles per hour, which is orbital velocity, and entered at 40-degree angle of attack, and which is like the direction of the air coming at it. The wings were pointed 40 degrees up from that, so it's like plowing through the atmosphere. Mm-hmm. And I don't know, it's just a behemoth if you've ever seen it in person. It's just insane. But it's noteworthy in this podcast, but there's way too much to talk about it to kind of there's too much there, so we're gonna maybe circle back to it at a later time.
Save it for another day.
Yeah, for sure.
Yeah, all right, so let's jump into some of the other successful space planes. One is called Buran, and that only flew one time, and it was developed by the Soviet Union, and it basically was unmanned, completed 2 revolutions around the Earth, and then landed back in its landing spot, maybe 10 meters. I think it was 10 meters from its target landing.
Wow.
Yeah, and what's crazy is that the project was canceled after the Soviet Union collapsed, and then it never flew again. They had one in storage, and the building collapsed, and then they just never rebuilt it.
Oh, really?
Yeah, so that one was pretty interesting. If you look at pictures online, it looks very similar to how the Space Shuttle looked. So that's basically all there is for that one. If we want to go and continue on to a few others, maybe Cole, you want to talk about Spaceship One and Richard Branson's company?
Yeah, so I think we've all heard of Virgin Galactic, which is Richard Branson's little space company of his own.
Space tourism, yeah.
Yes, specialized in space tourism. It's actually going to now start looking at suborbital launches and orbital launches of microsats and nanosats because they can't launch any of their normal spaceships.
Are you talking about Virgin Galactic as a whole or Spaceship One?
They're planning to use a variant of their Spaceship One and launch it from White Knight 2 and pretty much carry payload up to orbit. I'm not familiar. Can you explain these names? Yes. So White Knight 1 and White Knight 2 are gigantic aircraft. They're, I think, 2-engine and 4-engine respectively. These are jet engines, and they fly up to about to an altitude of about 50,000 feet, and then drop their payload. Whether that payload is a rocket or a manned vehicle, it completely depends on what they want to launch. They've launched one payload into suborbital space a few times, and that is the Spaceship One, and that was a single manned spaceship, and that was for an X Prize, which is a prize that someone donates money to, and they try to generate competition. Is that privately funded or publicly funded?
It's entirely privately funded. It's a $10 million prize, and it's basically the goal was to launch a reusable manned spacecraft into space.
Okay.
So Spaceship One won that.
Yeah, and they had to do it twice within the period of, I think, a month.
2 weeks.
2 weeks, yeah, which is even more impressive.
Yeah, that kind of changes my perspective because I don't know how long the spaceship or spaceship, how long the space shuttle's turnaround time was, but they pretty much had to rebuild parts of it between launches. And even SpaceX wants to reuse their rocket cores, their first stages. But even then, up to this point, we don't know how long it'll take.
How fast they'll do that.
Yeah.
Yeah, so the record for the fastest space shuttle turnaround was actually 54 days. So
54 days.
Yeah, it's a pretty long time. And there was an estimate of the cost to like refurbish a space shuttle after landing, and I think it was upwards of almost $1 billion. So SpaceX's goal is to dramatically lower that, and as well as the time, like almost day turnaround times is kind of what they're going for.
And that's not to like, the space shuttle is one of the most complex human creations ever. But that's not to say that like returning something from space is, you know, there's some rebuild time in between. So 2 weeks is insane to have something fly twice, even suborbital.
Sure. And I believe Spaceship One was immediately retired after they finished that. They'd only flow those 2 flights, and then that was it, right? Did you read that, Cole?
Yeah, that's kind of something that I gained from that. And I think part of it was because the company that made it, Scaled Composites, was commissioned directly after by Richard Branson, who bought the company. And he told them that they needed to make a ship that could launch 7 to 8 people into suborbital space. So
that's Spaceship Two.
Spaceship Two, exactly.
Yep.
I see. So they kind of scaled up the idea for Spaceship One. What does Spaceship One look like, by the way? I haven't seen a picture in a long time. It's one man. Okay, it looks like, I don't know. I've seen that before. I've seen that shape before, but it looks like a torpedo with
Yeah, I mean, it's
a delta
similar to
wing.
the X-15. You know, like the X-15 was dropped out of B-52. The Spaceship One is dropped out of White Knight One.
I mean, it works.
Yeah, the concept it does work.
It's got a bunch of portholes on the side. And Spaceship Two is a scaled up version that has 1 or 2 pilots, 1 pilot and 2 pilots.
So yes, Spaceship Two has 2 pilots, and it's supposed to, I think, have 6 to 8 passengers. And it is noteworthy because it has not gone to suborbital space yet. They have done hot fire tests, so they drop it from the spaceship, White Knight 1, and then they light the engine. However, their current test model has been destroyed. They feathered it, which is pretty much folding it in half during powered flight.
Why would you fold it in half?
So when you go up into suborbital space, you are out of the atmosphere. And when you come into the atmosphere, that's the most dangerous point. Point in the entire transition. You might sound kind of counterintuitive that maybe the most dangerous point would be when you have your engine firing, but in fact, when you're going back into the atmosphere, it's very difficult to control your angle of attack.
Right.
And by feathering it, you guarantee that you're going to have a good reentry. And that was one of the things about the space shuttle.
So, to talk about Spaceship Two. It changes its mechanical shape in order to make a better aerodynamic shape that's more hypersonically stable.
Well, in fact, it's completely not aerodynamic whatsoever. So it folds pretty much the back half of the ship upwards.
Like a giant spoiler, like something to make a lot of drag.
It's designed to increase drag, yeah, but it does make it more stable. So
exactly, so more stable, but not aerodynamic.
But well, I mean that makes sense, yeah, because when you're re-entering the atmosphere, you're going super fast in order to get into even suborbital. You're going super fast, so you want to slow down. So the Spaceship Two test article, you explain it.
They were in powered flight. Then they went into glide mode, and one of the pilots thought it was necessary to engage the feathering. And it is possible to feather in atmosphere. However, it is very dangerous, and you have to be under some very specific test constraints to do feathering in atmosphere. So they did that without the constraints consideration, and the plane ripped in half. And it required the 2 pilots to eject, and one of them did not survive.
I mean, it's dangerous. but they're building another Spaceship 2, and they're going to try again?
Yep. So that was the Enterprise that blew up in October of 2014. And then Richard Branson just announced the Unity, which last February he unveiled it. And that's the next Spaceship 2. And they added some software to prevent feathering in atmosphere. And basically, so this doesn't happen again, they added some other like pilot protocols and stuff like that. And that's currently undergoing ground system integration testing. So hopefully they'll have fixed all the problems, so we'll get to see that again fly soon.
Cool. And yeah, go ahead, Alex.
Are there any, let's say, like ejection safety measures or for the pilots or the passengers, perhaps?
Yeah. So one of the pilots ejected from the Spaceship 2, the last one that launched, and that's how I was able to survive.
Okay.
And so there's still, ejection methods and stuff like that. But obviously they want to make this as safe as possible because Virgin Galactic's goal is to open this up to commercial space flights. So basically for $250,000, you'll be able to pay Virgin Galactic and they will take you above the Kármán line of 100 kilometers, and you'll actually get to be in space. You'll get to see, the curvature of the Earth and all that crazy stuff that astronauts say is quite amazing to see, and then you'll come back down and land. So they're basically trying to commercialize that.
Right.
However, it is important to note that there is no emergency evacuation procedure for the passengers. So if your spaceship's ripped in half,
Right, that's why they might want to make it as safe as possible, which is always a huge consideration for any manned vehicle.
Exactly.
So beyond Spaceship 2, do you have any more successful space planes?
Yes. One of the actual space planes that's the last on the list, or one of the last ones, is ESA's Intermediate Exploration Vehicle. And that one has been launched once, and it is 5 meters long. And
5 meters?
Yeah.
That's...
Or it had a 5 meter long payload, sorry. Excuse me.
Okay.
And it has a 2-ton payload. And it is the unique one out of the bunch because it landed in the ocean. It actually had a splashdown.
Okay. Can you explain the form and function and mission profile?
Yes. So if you kind of imagine a delta wing and then take it to an extreme where it pretty much looks like a triangle.
Okay.
And it is plated heat shield. And its goal was pretty much to measure the reentry profiles of different reusable spaceplanes. This one was looking at testing scientific articles as well as potentially providing some insight into how the European Space Agency might create a new resupply vehicle for the International Space Station.
Right. So it was built in order to test experimental tech like reentry, heating and profiles, and some other stuff on board?
Exactly. It was wholly a test article.
Was it unmanned? Yeah.
Completely unmanned. Yeah.
And when it splashed down in the ocean, did it survive?
It did. They were able to recover what they needed. So I thought that was quite impressive.
Was it designed to splash down?
Yes, it was.
Oh, okay.
I don't think they. I think the Europeans, they don't have as much land to their that they can just kind of throw space shuttles. And
they are planning on landing one though, right? I mean, so in 2020, I think they're planning on doing the next iteration of this and landing actually on ground instead of a splashdown, either using a parafoil or landing gear.
Yeah, but just like our first space shuttle that ended up launching and landing, we landed in the desert, which is, if anything goes wrong, no one's going to get hurt,
right?
And no infrastructure is going to get hurt. In Europe, you're kind of you're pressed for space.
Yeah, I mean, a giant dry lake bed is kind of a natural runway too. So,
true.
And what's the last space plane you have on your list?
So the last one I have is the X-37. It is a Boeing-made spacecraft, and it is made for DARPA and the Defense Agency. So DARPA is the Defense Advanced Research Projects Agency, which is a sub-agency under the DoD, or Department of Defense. And this one is, as you might expect from a defense agency, very much
mysterious.
Yes, very mysterious.
I think that's a good word.
So it has had quite a few launches.
Can you explain what this one looks like too?
Yes. So this one looks like a bullet with small wings in the middle, and then 2 smaller wings at the back. And when I say small, I really do mean small. These are all but stubs.
Like control surfaces, right? Rather, they're not wings. They're just like
Look like shark fins or something. Yeah.
cool.
Yeah.
And how is it launched? Does it take off from a runway?
No, this is launched on an Atlas. I don't know the exact Atlas that they launched.
It's Atlas 5.
So it has had 3 launches. One of them, one of the launches has put the spacecraft in orbit and has yet to come back from that. And that's actually one of the notable things about this, is it stays up in space for quite a long time. We're talking years. And it visits things. So it does maneuver in space. It's not just like they put it in orbit and then it just kind of swings around the Earth.
So do we know this from declassified documents? How do we know about this?
We know this because people can have telescopes, and just normal citizens are tracking this thing throughout
Interesting.
orbit. There's one thing that you can't hide, and that's physics. And little bright objects zipping by and changing their orbital inclinations is something that's pretty obvious. You know, we have yet to have stealth technology get to a point where we can, hide those things.
Yeah. But
That we know of, at least.
this is super exciting. I'm not as afraid as maybe you guys might be that they're not sharing it. I know the military, I mean, they need to protect their research rights. They want to be more advanced than, quote unquote, the enemy. But the fact that they're doing experiments like this with a space plane that's maneuvering in orbit, it gives me a lot of hope for the future of reusable spaceplane technology. But I don't know. I just hope it comes back around so we can see it as civilians in the near term.
Sure. So eventually they'll hopefully declassify all this information and we'll get the results. But obviously, if it's still pertinent to national security, it doesn't make sense for them to publicly release any of that.
Yeah. And
Yeah.
go ahead.
Currently, there's a decent amount of speculation, as you might assume, and everyone's talking about maybe a satellite killer or satellite repair mechanism, because it does have payload. It can bring stuff up and then bring it back down, which is something that no one provides right now. Something that can go visit a satellite and then take that entire satellite back down. We don't know if it's actually done that yet, but it's possible.
Yeah.
The next thing is that they actually Boeing announced a third variant of it, a C. So there's been an A and B variant right now, and Boeing announced a C variant, and they did nothing with it. But the C variant would allow 6 astronauts to be put in the
Wow.
pressurized cargo area. So it is interesting to think about something that might be for use that isn't military.
Yeah, for sure. And for all these successful space planes, there have been some failures, but for different reasons. Like,
I mean, we can talk about the X-33. Basically, in the 90s, there was a space launch initiative that NASA sent out to find suborbital reusable space planes, and that's what the X-33 came from.
right. So the X-33 is basically a successor to the Space Shuttle. It was developed in the early to mid 90s and looks like just think of a space shuttle, except you know how the center is really tall, and then just make the whole thing kind of that thickness and one big wing. And at the back, it has 3 fins and an aerospike engine, which operates a little bit differently than a regular rocket engine. You're going to say something, Alex?
I would say in layman's terms, it looks a bit like a white pizza box kind of slice.
Nice.
Slice pizza box, yeah.
It does. Yeah. And it's designed to be a crewed vehicle. And I don't know too much about the specifics of the aerospike engine and other technology things. TJ does, and we might revisit the X-33 in its own episode. Go ahead, Cole.
Well, maybe shifting the topic from the X-33, which we might put an episode for its own. There's actually something that is potentially going to come into the physical world, which is the Dream Chaser. It's built by Sierra Nevada, and it's based off of the extensive research done for the X-33. It was initially made as a manned spacecraft and has now accepted the role from COTS 2, which is the Commercial Orbital Transportation Services Agreement 2, as an unmanned transport to the International Space Station. And this thing has a lifting body, as you might assume from any
Can you describe the way it looks? I don't have a picture in front of me.
So again, it looks like a single slice pizza box. So we're talking white and a triangle. So it does look similar to the X-33.
It's a little more rounded off, I think.
Yes, maybe a little bit more rounded off. But it's something to be excited for because it will actually push the numbers of space planes up to 7.
Yeah. What's unique about the Dream Chaser?
Well, other than the fact that it's actually going to get built, it's built by a commercial company, so it is out of the hands of NASA. It's one of the 2 instances that I know of where a company has come to NASA and just asked for all of its data that they've created and from their extensive research and then done nothing with because their project's gotten canceled. That and Bigelow Aerospace. So Sierra Nevada and Bigelow Aerospace are the 2 companies that I know of who've just gone to NASA and gotten a ridiculous amount of information to prop up their own business.
But yeah, so I think as a transition to that, what's important is what's really cool about the reusability aspect of it is that you can use better materials. So you can use better, more expensive thermal coating, stuff like that, because you're not just throwing it away after one flight.
Right.
So that's kind of why this has been the thing to chase. What's cool about space nowadays is that there are a bunch of different companies jumping into the fray. And when you have that, you really get capitalism working at its finest, where these companies are trying to innovate as best they can. So we don't just have, one massive military industrial complex where one company or 2 companies are kind of working together to just make, one super expensive object, and there's no incentive for them to lower the cost and the ability of it.
Right, but do you see commercial kind of like passenger air flight? Do you see that as taking away from, as a whole, as humanity, see that taking away from our resources at all? It's a lot of rocket fuel still to put, so a couple of people up there, right? In the bigger picture of things.
I'm not quite sure what your question is, but if we're talking just about funding, if you look at something like the commercial resupply missions and the money that NASA contracts out to other companies, it's actually significantly cheaper than the money that NASA's spending to internally develop things like the SLS rocket and its own capsule.
Oh, okay.
In terms of some other things that are being developed, Cole, you have this Skylon engine.
Yes, so Skylon, the company and the plane that they're hoping to create, and Sabre being the engine that they hope to build. So right now, the Sabre engine is the only one that's had a chance to come into reality. It is an air-breathing rocket propulsion system with the acronym denoting a symbiotic air-breathing rocket engine, or synergistic, sorry. And the interesting thing about this is it actually uses something that all rockets and space planes have previously fought against, which is the atmosphere. Every single rocket that humanity has built so far has pretty much had to go through the barrier that is the atmosphere. And this space plane takes the atmosphere, which has previously been a barrier, and turns it into actually an asset. So the interesting thing about this is it actually super cools the oxygen in the air and then feeds it into a compressor and then mixes it with liquid hydrogen and then burns it.
So like a regular rocket engine that uses liquid oxygen and hydrogen, like for regular launch vehicles, this is kind of doing the same thing, bringing its own hydrogen along and then using the oxygen that's in the surrounding intake air to its advantage.
Exactly. And when it leaves the atmosphere, it uses its onboard supply of oxygen. It has a tank of oxygen to then supply the oxygen that would have been found in the atmosphere. So it's quite an exciting idea. It is quite far away from becoming a reality right now. SpaceX, Blue Origin, and these other companies that are hoping to create reusable rockets will at least have 10, 15 years of full-on use before this plane comes into reality. However, some big players such as the U.S. Department of Defense has actually put money into this engine.
Great, that's pretty cool. We were talking about this earlier as well, and you say it's supercooled. It supercools the oxygen that goes into the intakes. So when it's going super fast, I guess that the air in front of it would heat up, and then in order to use it in its engine, it needs to be cold. Does it? Can you explain that a little bit?
Yeah. Well, I mean, if you think about it, right? Depending on your knowledge of chemistry, atoms move. They shake, and when they're shaking more, they take up more space. So, in order to create a reaction, you need to have a balanced reaction. You have to have a certain amount of hydrogen combined with a certain amount of oxygen. And depending on how much, what that ratio dictates, you have to supply that. And
so in order to get enough oxygen to mix with the hydrogen that you've brought along, the air is not dense enough, and so they take in the feeding in oxygen and condense it down.
And to condense it, you have to cool it to, slow down that vibration, make them vibrate less. And then you have to put it through a compressor. So they're nearly making it liquid. They are not making liquid oxygen, but they're getting very, very close.
Yeah. That's awesome. And where are they at now with development?
So they have created their engine. They've created a reaction engine to test the cooling, which is one of the biggest issues. That was one of their biggest hurdles. A lot of people said that they couldn't do it because the fact that they needed to cool oxygen from ridiculous temperatures down to, again, ridiculous temperatures
in the other direction
in milliseconds. And they have tested that, and they've tested the compressor with that. So they have created thrust. However, they've not yet done any mixing. I think that's one of their next steps. So they're testing different arrays to do that.
Cool. That's all I had about Spaceplanes. But before we end the podcast, I did want to give a shout out to Daniel P. He sent us an email. He said, "Great podcast, guys. Keep them coming. I found everyone great to listen to. Thanks, Daniel P. P.S. Please sort out the audio quality. The content is great, but the sound quality can be hard on the ears." We know. I just want to say thanks. And thanks for writing in. It's really great to hear from people that are actually listening. We do get a little bit of stats in the form of numbers for how many times our show has been downloaded per week, and the location. So we've got a worldwide audience, actually. Lots of people from the US, Canada, the UK, Germany, the Netherlands, like lots of people listening. And I'd love to hear from people. And thanks for toughing out the audio problems. We do have a few microphones, and we haven't had a permanent space to record. So we've been trying different things, having different people, trying different setups, and seeing what works. But we're definitely working hard to improve it, and I think it's finally paying off.
Keep the feedback coming.
Yeah, and to add to that, once again, we mentioned in the last episode, we will be recording a live episode at Imagine RIT at the Rochester Institute of Technology in Rochester, New York, on May 7th. That's a Saturday. It's when the university is open to the public and everybody can come and see the cool stuff that the whole university is working on. And we'll have a show, and we'll be talking to Kevin Cook, who's an astronomer at the university, and we'll be asking him some really cool questions, including your questions. So if you email it to SPEXcast@gmail.com or tweet your questions to RIT-SPEX, we'll pass them along to Kevin live, and we'll see how he answers. It'll be a lot of fun. So that's all I had for this episode. We'll be back next week with another discussion on space exploration, science, and technology. If you want to share your thoughts, have your questions, requests for future episodes, or just general feedback, send them to SPEXcast@gmail.com. Tweet to us at RIT-SPEX. If you want to hear more, consider subscribing to us through iTunes or your favorite podcast app, and all past episodes are available on our website. This podcast has been made possible by RIT Specs, a space exploration student faculty research organization at the Rochester Institute of Technology. Special thanks to the Interactive Learning Grant Program for giving us the tools to promote student and faculty engagement outside the classroom. Our music is by Kevin Hartnell. This has been SPEXcast. We'll see you next week.